We're still on the laws of logarithms. We have gone through about 5 laws of logarithms. So next, we're going to look at some more engaging logarithmic expressions and then see how we can apply the laws. On the right hand side, we have the laws of logarithms that we have considered so far. Laws of logarithms. We have 4 problems here to look at. So let's take them one after the other. Number 1 says we are also to simplify logarithm of what? 98 base 7 minus the logarithm of 30 to base 7 plus the logarithm of 15 to base 7. Now the first 2 laws can handle this in the immediate. Where we have minus, we are supposed to divide. Where we have a plus, we are supposed to multiply. So writing this as a single logarithmic expression, we'll say this is logarithm. 98 is positive, so we'll have it there. Now this is minus, it means you're going to divide by 30, and then plus means you're going to multiply by 15. Remember, to base 7. And what does this imply? Simple arithmetic there means you're going to write this as 98 times 15. Divide by 30 means the 30 can go downstairs, and we have this to base 7. Sorry. Now we can play this out. 15 there is 1, 15 there is 2. 98 divided by 15, sorry, 98 divided by 2 will give us 49. So we have here the logarithm of what? 49 to base 7. Which is what we have here. So we have been able to simplify so far, but we can still go further. We can apply, look at 49. 49 can be expressed as 7 raised to the power of 2. So we can write this as the logarithm of 7 raised to the power of 2 to base 7, and then apply this rule that says that this exponent 2 can be sent to the back side. So we have that as 2 log 7 to base 7, and again we can apply this other rule that says that the logarithm of a number to the same base is 1. So log of 7 to base 7 is 1. So I can write this as 2 times 1, and that gives me what? That gives us 2. So that's it for the first question. Let's move immediately. I'm sure we are all okay with that. So that's it. 2 times 1. That's 2. You can see there 7. 49 giving us 7 square. And then the 2 sent to the back. And your log of 7 to 7 is 1. And then 2 times 1 gives us 2. Next problem. Sorry. We have log of 5 over 7, the logarithm of 5 over 7 plus 2 log 7 over 6 minus the logarithm of 5 over 6. Now before we can apply the first rule that handles the positive sign, the plus and the minus, first we have to look for how to take away this 2 from this position. What do we do? Remember, this 2 must have come from up here as an exponent. So at first I'll transfer this 2 inward and rewrite this line as logarithm of 5 over 7 plus, instead of 2 log 7 over 6, I will now write this as log of 7 over 6 raised to the power of 2. Yes, because this 2 came from here, there. And then minus the logarithm of 5 over 6. So now I have all logarithms standing on their own. So I can apply the first and the second rule. Where I have plus, I'll multiply. Where I have minus, I divide. So I'll simply say this is equal to the logarithm of 5 over 7. The plus means I'm going to multiply by 7 over 6 square. We can write this as 49 over 36. And then divided by 5 over 6. Now this takes us to, let's write this in a more simplified form. This will be log of 5 over 7 times 7 squared is 49 all over what? 36. And I change the divide to times, and I have this as 6 all over 5. Let's clear our board a bit. Okay. Let's explain what we have here so far. Of course, from here, we can see the 2 was moved up. There we have raised to power 2, and then we have 7 squared, 6 squared, giving us 49 over 36. And then the next thing is to combine this into the log of what? 5 over 7 times 49 over 36, and then divided by 5 over 6. And that's it there. After doing that, you will definitely arrive at this. That's it divided by. So I'll take this back again. Let's simplify further from here first before we move to the next screen. This will give us the logarithm of, I think this is more simplified. We have here 5 over 7 times 49 all over 36 times 6 over 5. I was taught this in primary school. So this can simply be written as the logarithm of 5 times 49 times 6 all divided by 7 times 36 times 5. And that's what we have in the next slide. Yes. So that's it there. Logarithm of 5 times 49 times 6 divided by 7 times 36 times 5. And then we can do some cancellations. This 5 can take care of this 5. The 7 here can take care of this 1. And then we have 7 there. 6 here is 1. And 6 there is 6. So we have just 7 over 6 left. So this will give us the logarithm of what? 7 over 6. You can leave it that way, or you can simplify further. Applying this rule, we can move from right to left and write our log 7 over 6 as log of 7 minus the log of 6. Still the same thing. And that's it there. So that's the final simplified form of the expression log of 5 over 7 plus 2 log 7 over 6 minus log of 5 over 6. Now next we'll have here that if log 2 base 5 is given as 0.431 and log 3 base 5 is given as 0.682, we are to evaluate the log of 12 to base 5. How do we do this? Now this is a very simple question. Since we have been given log 2 base 5 and log 3 base 5, then we must find a way to write our 12 in 2s and 3. And looking at 12, I see 12 as 2 times 2 times 3, which means I can write my log 12 base 5 as the logarithm of what? 2 by 2 by 3 to base 5. Now log of 2 by 2 by 3 to base 5. Applying the first law, moving from right to left, it means I can split this out as the logarithm of 2 plus the logarithm of 2 plus the logarithm of 3 all to base 5. And which implies, therefore, if I can move to the next screen, you can see there we have splitted that, and we have this as what? Log 2 to base 5 plus log 2 to base 5 plus log 2 to base, log 3 to base 5. Now log 2 to base 5 has been given to us as 0.431, and this is given to us again 0.431. That's log 2 to base 5, and log 3 to base 5 is 0.682. Adding this up, we have there, and that takes care of question number 3. Finally, next question, we have here again that we should use what? That log 2 to base 5 is equals to 0.431. log₃ to base 5 is equal to 0.682. Using these two values, we should evaluate the log of 13.5 to base 7. The problem now is how do we express 13.5 in 2s and 3s? The first thing I can see here is that my 13.5 is 13 and a half, which can be written as 27 divided by 2. So I quickly state that out, that log of 13.5 to base 5 is equal to the log of 27 over 2 base 5. I can see 2 is beginning to come out, and I can also see 3 coming out gradually from the 27. But first and foremost, I look at 27 over 2. I can move from right to left, looking at this second law here, and write this as the logarithm of 27 base 5 minus the logarithm of 2 to base 5. I'm sure we'll all agree. That's it there. So now we have been able to reduce our logarithm of 13.5 to log of 27 base 5 minus log of 2 base 5. But look at what we're given. We're given log of 3 base 5 and log of 2 base 5. 27, how do we deal with this? Oh, I look at 27. 27 is 3 raised to power 3. I say, okay, I can write this as the logarithm of 3 raised to power 3 base 5 minus logarithm of 2 to base 5. I think I'm running home now. Now I can move this 3 down to the back following this law. So I write here 3 log 3 base 5 minus log of what? 2 base 5. Now I can just substitute. This is 3. Log of 3 base 5 has been given to us as 0.682. So I'll throw this away and bring in 0.682 minus log of what? 2 base 5, that is this, and that gives me 0.431. And we simplify there. 3 times this will give me 6. 24 take 2, 18, 19, 20, if I'm not mistaken, minus 0.431. Let's clean our screen a bit. So that's it there. You can see our 27 was changed to what? 3 raised to power 3, and then the 3 goes to the back. And then we move further, substituting the value. Log of 3 to base 5 given to us as 0.682. Multiplying that out, we have 2.046 as we obtained earlier, and then you subtract 0.431 to arrive at 1.615. So the logarithm of 13.5, we can see using the values given to us above is 1.615. That brings us to the end of the laws of logarithms. Next, we'll be looking at using logarithmic expressions in solving equations. So from our next video clip, we'll be considering logarithmic equations.